Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Darush bin Saidin. My supervisor is IR Suryadi Sojito. My co-supervisor is Puan Nur Aina Misnu. I will present my poster for our final year project titled Simulation of Fire Performance of Steel Plate using LS Dyna. Steel plate is used in building construction because of its easily fabricated properties that can be used to produce massive steel structure. Steel plate sections can be produced off-site and then assembled on-site. This property saves time and it will help in the efficiency of the construction process. Steel plate is very flexible, but there are disadvantages in steel plate. Steel plate has small resistance to fire as compared to concrete. Steel plate reduces when the temperature rises to 600 to 700 degrees Celsius. There are also extensive fireproofing costs involved as steel is not fireproof. In elevated temperatures, steel loses its properties. This can be detrimental to the overall structure. The objective of this research is to simulate the fire test on steel plate, and the second objective is to evaluate the fire performance of steel plate. LS Dyna is a general-purpose finite element program capable of simulating complex real-world problems. It is used by the automobile, aerospace, construction, military, manufacturing, and bioengineering industries. LS Dyna is optimized for shared and distributed memory, Unix, Linux, and Windows-based platforms, and it is fully owned by LSTC. The code's origins lie in a highly nonlinear, transient, dynamic, finite element analysis using explicit time integration. LS Dyna's potential applications are numerous and can be tailored to many fields. In a given simulation, any of LS Dyna's many features can be combined to model a wide range of physical events. An example of a simulation which involves a unique combination of features is the NASA JPL Mars Pathfinder landing simulation, which simulated the space probe's use of airbags to aid in its landing. LS Dyna is one of the most flexible finite element analysis software packages available. LS Dyna consists of a single executable file and is entirely command line driven. Therefore, all that is required is to run LS Dyna is a command shell, the executable, an input file, and enough free disk space to run the calculation. All input files are simple ASCII format and thus can be prepared using any text editor. Input files can also be prepared with the instant aid of a graphical preprocessor. LS Prepose is an advanced pre- and post-processor that is delivered free with LS Dyna. The user interface is designed to be both efficient and intuitive. LS Ribbon runs on Windows, Linux, and Macs, utilizing OpenGL graphics to achieve fast rendering and XY plotting. Example of uses is geometric regression and meshing, LS Dyna model visualization, LS Dyna model editing, and advanced post-processing. The pre-processing process is done by using LS Prepose software. The type of input file is K file, and it can only be read and processed by LS Dyna software. The LS Prepose will be used to create the material model of steel plate of desirable properties and thickness. After the boundary condition is set, the model is drawn according to the boundary and the properties of material is specified in the details of the material model. The completed material model will be exported as a K file to be processed in LS Dyna. During the simulation process, LS Dyna is used as a simulation platform to investigate the fire performance of steel plate. The K file that was imported from LS Prepose is processed to simulate a 30-minute and 1-hour fire rating. I analyze the data to post-processing stage to evaluate the results that are obtained from simulation in LS Dyna by using LS Prepose. From my research, the results show the behavior and the fire performance of steel plate under fire condition is according to the ISO 8341 standard fire test, as shown in the figure below. That's all from my poster presentation. Thank you for your attention.